ProcessVue Alarm Intelligence is a large language model that enables the users to interact with the entire ProcessVue suite using natural and normal language. It's going to unify our products so that you can achieve faster decision-making, adaptive analysis, smarter and more efficient investigations, and it's going to empower all users to make a change in alarm management without needing that expertise or that experience. It's going to allow you to unlock the full potential of your alarm data. And you don't have to just take my word for it. I will actually show you. Okay, so this is the interface. You can see that it's a chatbot type interface. So I'm first going to ask it, what are my top 10 alarms for April? You can interact with it just like you would ChatGPT, but the extra value here, or the value that's specific to alarm management, is that it is layered on top of our software. So it's connected to our databases in the background. So while you can talk to it and ask it any sort of questions, it also has that alarm data that it can reference and refer to pull information and do all of its analysis. So it's querying the database right now to figure out what my top 10 alarms are for April. And as you can see, it comes back with a response, a list of my tags and the counts, and then it tells me how it got there and then asks if I want to, it proposes other things that I can ask. And because I am utilizing this on a laptop, I anticipated that it might be a little slow. So I did prepare some chats that I think show off the capability of this new feature. So for the sake of time, I am going to refer to those, but I wanted to show you how you could interact with it and how it would respond and operate. So in this chat, I piggybacked off of my initial prompt, which was, what are my top 10 alarms for April? I asked, what are my top 10 chattering alarms for April? And it comes back with a list of my chattering alarms, and it tells me the chattering count. So I noticed that my top chattering alarm has a count of 17, and it's A38. That's the tag. So again, it tells me how it arrived at that. But say I am looking to reduce our overall alarm count, and I think chattering alarm would be an easy win. So I ask, what kind of on delay do you suggest to remove those alarms, and tell me the percentage of reduction that I'm going to see. So then it starts looking at the different durations, the number of occurrences, how many of those occurrences are chattering, total alarm count, and it comes back and it recommends a timer of 20 seconds. And then it tells me this would eliminate 9 of the 17 chattering occurrences and reduce my overall alarm count from 54 to 45 on this tag. And then it tells me that's a 16.67% reduction in total alarms. But if I'm not comfortable with a 20-second delay, it also provides alternative timer settings, 5, 10, and 15 seconds, and then the rate of reduction that you would see with each of those. And so say I decide, that's great, I do want to implement that 20-second timer, but I'm getting pulled away to go do something out in the field, then I can quickly tell it, okay, create a work list item in Analyzer for this tag, give it this comment, and assign it to Jana. And then it's going to show me that it starts querying the work list within the database. It assigns it an ID of 2014, and then it summarizes all of the words that it used and what it's done in Analyzer to create this work list item. So let's check out if it did it or not. Okay, so this is our nuisance alarm work list, and as you can see, we have an item. It is work list number 2014, and it is for tag A38. The cause is chattering alarms are detected. The assigned task is to implement a 20-second on delay timer to eliminate chattering alarms. It's assigned to Jana, and the additional comment is that the analysis shows that 16.67% of alarms are chattering with intervals between 2 to 20 seconds. So you can see it captures all of that, the important information that we discussed in that chat. And then I can come back and review it later, or someone on my team can. So that example was actually inspired by something that I was actually asked to do, which was to create a tool that basically did the same thing. It would pull the data, understand the durations, and then plot different delays and the percentage of reduction on a graph for each tag. And so, or for each alarm. And I'm sure you can imagine that took several days of engineering time, and I just accomplished it in a matter of minutes using this alarm intelligence. So another cool experiment that I did with it was trying to understand the predictive analysis capabilities. So again, what are my top 10 alarms for April? But this time I want to include it in there, include the plant area. So I see my top 10 alarms, and as I'm scrolling through the data, I notice that PA3 is typically or is most commonly associated with those top 10 alarms. And so I also realized, okay, well, maybe PA3, that plant area, has experienced a lot of trips recently. So I ask it, are there any alarm patterns that suggest we are heading towards a trip in this plant area? It tells me I just asked it a great question, but it can't find any data. It keeps trying, it modifies its query, and it updates me that it's still trying, communicates very well. And then all of a sudden, it gets really excited and says, okay, now I can see the alarm data. And it lets me know that it realized that some of the plant areas were stored with a leading space while others were not. But it was smart enough to pick up on that and to realize that it's the same thing. So it continues with the analysis. And it provides the data in the table form, but then it normalizes that data and communicates it in normal language. So it picks up on different patterns within the chattering alarms, high frequency alarms, the alarm priority, recent activity, just some basic pattern analysis. And then, but because I want to make sure that it's taking into account that historical context, because I think that will make for better prediction, I ask it, do any of these alarms historically precede trips, just to make sure. And so it continues to do a deeper dive into the analysis. It gives me some more specific alarms that are key trip precursors, and then different observations and the risk assessment. And then at the end, it says, would you like me to analyze any specific alarm patterns in more detail or provide recommendations for monitoring these precursor alarms? Well, I decide, okay, maybe, but I still want to see it in more of a timeline view. I'm a visual person. I'm not fully convinced that it is truly related to incidences in the past. So here it is. It pulls the data. It starts associating dates and times with it. And then it plots that on a scatter plot for me with the minutes leading up to the trip, and then the alarm count per tag in those minutes. And if I don't like the way that data is displayed, it does it again for me in more of a bar graph kind of format. And then it recaps the pattern analysis that it's just done with reliable precursors, timing patterns, early warning indicators, all of these different types of triggers. And then it says, would you like recommendations for implementing an early warning system? So if I'm not already impressed by the pattern analysis that it's done, let's see how well it does when I ask it to recommend an early warning system. So I follow through and I ask that, pulling data, and then it comes up with this early warning system that is made of 3 tiers: a trigger or a watch tier, a warning tier, and a critical tier. And then it gives me the trigger conditions for each of those tiers, and then responses that it suggests when those triggers occur. And then it gives me different ideas for how to implement this early warning system, and then a risk assessment. So then, because I like numbers and I want to know the value that I could add, I ask it, if this warning system was in place, if I did do this, what percentage of my previous trips could I have avoided? And it comes back, it does an analysis on the previous trips, and it tells me right there in bold that implementing the proposed early warning system could prevent approximately 52.1% of trips. And then it highlights the different tiers and the reduction of those trips by tier. And if that is not impressive, I don't know what is. I just avoided or potentially reduced the trips by 52%. So now I realize I'm a really great employee. I reduced that amount of trips in just a few minutes. And so I need to tell my boss all of the great things that I've done, but that is a lot of information to digest and to summarize. So I tell it, write me an email to my boss summarizing this info, focusing mostly on the implementation. So it writes this long, detailed email that is full of great information. But let's be real, my boss isn't going to read all of that. So I ask it, can you make it even shorter? And it comes back with even the subject line, but a quick summary, the system, different benefits. There it is, right on top, 52% reduction, and then next steps. And then you can see it even has the signature right there, regards with your name. So you can literally copy and paste this into Outlook and send it to your boss. And so I think that there is a lot of potential in this feature and that it could transform alarm management. And if alarm intelligence is something that piques your interest, I would encourage you to follow us on LinkedIn to stay up to date with any information or release dates regarding OV alarm intelligence. And if you're interested in any of our products, you can find more information about them at our website, ProcessVue.com. If you're interested in reviewing the content of this webinar, that will also be posted online. And finally, if you do have any questions, you can email us at questions@processvue.com, and we will look to respond to those in the next few days. Thanks for attending this webinar. I hope you enjoyed it, and I hope you enjoy the rest of your day.